All right, and with that, it's now time for our next presenter on today's MegaCast. Excited to welcome back Mr. Craig Theriac, Vice President of Product Management at Scale Computing. Hey, Craig, it's great to have you back on.
Hey, David, good to talk to you again. See, we've got a couple Craigs
Well.
back to back. We'll keep this easy for the listeners here.
That's right. That's right. All right, well, take it away, Craig.
Perfect. Yeah, thanks for having me on, David. It's been too long. We'll have to catch up again soon. But so let me start by actually, it's interesting. I got to catch the tail end of the prior conversation. I think it leads really well into what I was planning to talk about today with what we titled The Pilot's Guide to Edge Computing. In reality, it's, I was kind of asked to talk about crafting a transformed IT blueprint, and then the context of my company in Scale Computing, it actually said it kind of dovetails into what you were just talking about with HCI and hyperconvergence in general. And so when I think of the IT blueprint through the context of our company, I'm thinking of large edge companies or large distributed companies that are deploying edge solutions like Del Hayes, and Ahold Del Hayes company. Now, this is a multi-billion-dollar grocery retailer based out of Belgium who came to Scale Computing looking to replace their IT infrastructure on site across some 800 individual locations. And a blueprint is just a set of plans. It's a guide to follow. For Del Hayes, their blueprint was really to deploy Scale Computing in place of single servers that they were deploying at the time, kind of point solutions. Hadn't even really made the way into virtualization yet. We're just kind of going on and on, coming up with the next application that would come down the pike. They'd have to deploy additional hardware on site. And obviously, that's not sustainable in today's world, in today's pace. And so just, again, thinking through the lens of what that looks like with Scale Computing, that's what came to my mind. So instead of saying, here's the blueprint they went through, I thought what I'd do today is just kind of talk through the edge computing space, what we're seeing in terms of trends and how people in general are trying to approach this, and what we're seeing successfully done at Scale Computing. So, obviously, in addition to everything that was just said in the last presentation, the businesses that are out there successfully deploying digitalization capabilities in their environments are doing so for really three reasons. It's access to new information, it's implementing new business processes, or possibly just innovating in the customer experiences that they're putting out there in terms of the people that are interacting with the data and things out on their network, out at the edge of their environment. And this movement, it's really ushering in new applications, as we just talked about. It's a lot of cloud-native applications. It's containerization. It's not just the legacy IT applications that people have become accustomed to running in that environment. And IT administrators are now having to weigh these new applications and trying to say, do I take a cloud-first approach to this, or do I run something on premises? And kind of when I'm in a conversation with the customer, again, I'm in product management, so not really trying to sell. I'm just out there trying to gather information. I love to ask customers, why not deploy this in the cloud? If you're talking to us, you've already made the decision you're going to run something on premises, but why would you do that? The cloud has all sorts of advantages, right? It's unmatched scalability, compute, storage resources. It's really highly automatable by DevOps. Talking about the tooling that people are used to be able to deploy cloud-native applications. That's a great place to do that. Little overhead in terms of management for IT infrastructure teams for sure when you're deploying the public cloud. But as it turns out, that the common responses that I hear to that question when I'm talking to those customers fall into about four different buckets. First one's data explosion. They're just creating so much data that it's either not even an option to get it to the cloud, or they just can't afford the bandwidth to put in place to get that data to the cloud, or maybe it's just a kind of nature of the application itself may have a decaying useful life, such as like a video-based application. Unreliable internet connectivity. And in the case of that Ahold Del Hayes that I just mentioned earlier, that grocery retailer actually had a lot of very remote sites that weren't able to consistently connect to the internet. So they just couldn't rely on that. And so they needed a consistent approach across all of their locations. And so, having something on premises was a must for them. Low latency is probably the most common thing that I hear these days, although I would expect over the next 5 or so years that's going to change. But low latency basically just means, hey, I can't wait for the latency requirements of getting to and from the cloud for the data that I'm trying to either write or access. I need something local to be able to make real-time decisions. Manufacturing environment's a great example of that. If you're doing anything with computer vision or AI machine learning workloads where you have to make split-second, even sub-millisecond decisions, you can't wait on that latency of the cloud. And then I would say the final bucket that things fall into is just regulation. So HIPAA, GDPR, a given geo or industry where it's forcing data gravity, where that workload needs to remain on premises. So kind of taking the next step here, most companies that I'm speaking with are trying to leverage some benefit, right? It's not that they're just deploying applications for application's sake. There's some business benefit they're chasing, usually brought in by some business line manager coming to IT saying, hey, I want to run this new workload, track store traffic in the case of a retail example, or maybe some sensor gathering new data you didn't even realize you wanted to track before, and maybe a manufacturing floor type of environment. These requests are really being made without realizing the burden that it puts on the IT team who is in charge of deploying the infrastructure behind that. And there's just this inherent friction that exists that's hindering your overall company's ability to execute and really adapt and improve these business outcomes over time. Now, obviously, IT is there to help. I mean, that's what it's charged with, to be able to help the business. And I would say every customer that I speak to knows this inherently, and they espouse that. But a lot of them are really stuck in these tough decisions based on just past infrastructure implementations, right? They're either doing point solutions like I described with Delays, where they were running individual desktops, maybe running Windows 7, Windows 10, maybe Windows 11, all the way through to maybe they're running a hypervisor out there on a couple of hosts, potentially with high availability, but then again it comes with the cost of complexity that comes along with that. So what is needed in this environment is something beyond just what's provided by these legacy approaches that I've been talking about. What's needed is kind of a different mindset that is a little more forward-looking, a little more strategic in its approach, and that's what edge computing really is all about. So I probably should have started with this, and I said I missed the very beginning of the last presenter, so he may have covered this as well. This is a pretty common definition of this, but really, what is edge computing? It's simply just a place at the edge of the network where people and things are interacting with the data, sometimes generating, sometimes processing, sometimes both. Edge computing then is that platform to run those mission critical applications outside of the four walls of the data center. And what's I would say really unique to this use case is that it is not a tier one data center. There's nothing really predictable in these environments like you have in a tier one data center. And so because of that, you're faced with a lot of constraints, right? There's limited IT staff, you've got physical constraints, there are connectivity issues or outages you've got to deal with. I mentioned the unpredictable demands of new applications coming your way that you just don't even know. The edge is messy. And when you're creating a blueprint, you really have to take into account these differences between what you're running out at the edge of the network and what you're running in, say, a tier one data center. I mean, if you have zero IT resources on premises, how are you going to deploy this? Are you going to work with a managed service provider to get that out to the site? Are you going to have an integrator stage things first? I talked with a customer just a couple weeks ago, and they don't have a keyboard, video, or mouse on site. So it's not like you have somebody that can even plug into these systems to deal with them. How are you going to handle failures? Break fix is a big part of deploying infrastructure, anything that's physical out at the edge of the network. And ongoing maintenance of the solution involves not just the physical nature of it, but also applying updates, everything from the firmware, the BIOS, kind of everything to protect yourself in a world of ransomware, as the last speaker brought up at the end. Now you have to think through the physical constraints as well. The form factor can really be important. We've got a lot of customers that are deploying on things as small as, say, the Intel NUC, which is a small form factor, very powerful, but very small and quiet design, and that's often chosen because it can be deployed under a desk somewhere, or kind of in an environment where noise might be an issue. Are these things going to be located next to people in an office setting where the fan speed is going to annoy them? Do you even have consistent power to be able to run these? And air temperature is another one that commonly comes up. And I'll walk through a use case later today, or later in this presentation, of somebody that's deploying these out at sea, and just kind of the differences in these physical attributes that you just don't have to deal with in the tier one data center all have to be taken into account when you come up with that blueprint. How are these applications going to be deployed? Are you going to have application level availability, which is fairly common sometimes in some of these kind of Kubernetes deployments, or just container-based deployments where you've got container management systems sitting there to manage and monitor that? Or are you going to rely on the infrastructure to provide that level of availability? And then ultimately, how are you going to respond the next time a business leader asks to implement some new application you didn't really account for whenever you set up the initial infrastructure and when it was deployed? And so all those things have to be taken into account. And ultimately, obviously, you're looking for something that provides the availability you need for your environment. It has to be simple to set up, simple to manage in an ongoing manner. you need to have a level of efficiency. This is so, as I said earlier, HD3, our main product, is a hyperconverged solution. And the last speaker was absolutely right. I mean, I would say most of the HDI vendors out there have quite a bit of overhead when it comes to the software design that they have, just in terms of compute resources required to run those storage services. With a product like ours, HD3, you can deploy these on really, really small form factors and maybe only have 4 gig of RAM or less dedicated to the operating system, where the rest of that can be available to running those workloads. So efficiency matters, especially when you're multiplying this out at multiple sites at scale. And then finally, flexibility. It's something that has to be able to scale out to match the needs and requirements of your environment as things change over time, because you're not going to know what's coming down the pike, and you have to recognize that up front. So all that said, is this brings us to the HD3 product. So HD3 is a hyperconverged product. It's combining the storage, the servers, the hypervisor, and disaster recovery capabilities into a solution that allows you to run legacy applications right alongside these new modern applications that people are moving toward. And it wraps it up with a fairly simple to use user interface with full management orchestration that can be done centrally. So you don't necessarily have to have full access to these sites physically. You can monitor these remotely. So I thought what might be useful would be to walk you through the product itself. And this assumes that my screen sharing works, so let me try that real quick. And David, if you could just verify that this comes through when I hit share. Is that coming through at all?
Looks good. Yep.
Perfect. All right, cool. Good to hear. All right, so what you're looking at here is what I would call our HD3 fleet management user interface. So this is a centralized, cloud-based fleet management system that allows you to connect into all of your HD3 clusters that might be sitting out there at all of the individual sites, or maybe multiple clusters even at an individual site, and manage them and monitor them and orchestrate them just from this one single interface. So I can put in my local credentials, or I'll just use single sign-on so I don't have to type anything. And here I'm presented with my dashboard. So this is across my entire fleet of HD3 clusters. Now this is our lab, so there are all sorts of issues going on in this lab, as you can see, based on the red alerts and orange alerts here in the user interface. But if this were the very first time you were logging into the system, you might have a much simpler interface to deal with. You might have just a single cluster. And I thought what might be useful would be to walk through what it looks like to deploy a first cluster of this. And David, sorry to ask this again because I had to switch tabs on you. Are you able to see just this individual cluster that says Scott Demo at the top?
Yes, I see it.
All right, perfect. Yeah, so this is an individual cluster. This is actually our HE150. It's a NUC-based platform. Each of these nodes is running 16 gig of RAM. And ahead of the demonstration, I plug these things into a rack. Actually, I think these ones are sitting on a cabinet shelf somewhere. Plugged it into power, plugged it into networking, assigned an IP address to every node in the system, and then initialized it. And then that process registers it with the HD3 platform that allows you to manage this at scale. So think of this as full HCI in a small form factor, ready to roll out of the box in less than an hour. And everything that I just described there is it's a fairly simple process. As I mentioned, manually it takes about an hour. But if you're creating a blueprint for deployment of this type of thing, it's not just about deploying a single site, it's deploying at scale. And so some of the things you want to think through are, are you going to automate the provisioning of this? Do you want to use things like kind of a staging area, either at your site or maybe through an integrator where you're providing all the IP address information and assigning that with MAC addresses? We do have the capability, which we see pretty commonly used, where you're taking a USB with all the configuration details, just in the back of the nodes, and all these things spin up so that you can go from unboxing to being up and running without even ever having to manually log into the system to check anything. And so part of the blueprint of deployment of this isn't just the, how am I going to get these things out of sites? How do you actually stand up the cluster and make sure that the applications themselves are being pulled in and running on the system? So again, this is a 3-node system. I thought what might be fun would be to walk through creating a new virtual machine on here. Really any cloud native application, containers, VMs, everything really can be run here centrally on individual nodes. I'll give this a name, description, select an operating system, maybe select an ISO to boot from, and click create. And that's all I'd have to do to manually create a virtual machine on this system. And I'll go ahead and start this up. Obviously, if you are doing this at scale, it's not about logging into every individual site and creating a VM just like I did. This is really just to show off the simplicity of the product. But in reality, we have a full REST API, and you're likely going to script up the installation of the workloads that are running on your site or out at each of the individual sites. And I would say that we also have some of the more advanced capabilities built into this, like Cloud Init, that allows you to kind of hand off ththese REST APIs to DevOps to interact with as infrastructure as code, so that they can go from automatically deploying not just the virtual machines, but also the containers and Kubernetes environment as part of a full CI/CD pipeline. So here I've started this VM up. The nature of edge computing means that these nodes and these clusters have to be able to operate autonomously. So if you are running critical workloads out at the edge of your network, you have to make sure that they are designed so these applications will maximize ultimate uptime. Part of that in how we deploy this is through what we call state machine technology. So we are constantly monitoring thousands of conditions on every node in the system, and we're kind of using those conditions to be able to make decisions like, all right, so I've just turned this specific VM from offline to online. That's a state change from offline to online. Now I'm going to set that on one of the nodes based on availability at that point in time. Another condition that's just popped up on the screen here is a warning of insufficient memory to start all VMs on alternate nodes, which is kind of a useful thing to know if you're going to be operating at scale and somebody gets started up workloads in that environment that don't allow you to be able to tolerate things like a node failure or even rolling upgrades, which are included in a scale computing system like this. So at this point, because these conditions exist, this warning, what that means is that if this host fails, I actually don't have enough RAM available here to restart all the workloads from this node on the other nodes in the system. If architected correctly and you don't have those conditions that exist, you would be able to just fail those over. And as an administrator, you don't have to have somebody on site. You don't even have to log in to make sure that happens. That just happens automatically. And so as the administrator, you're going to receive alerts through syslog. You're going to receive alerts through email. You likely will have a team of people, and I'll switch over to this other tab here, where you can see that you'll probably have a team of people monitoring this centrally. And as those conditions pop up on the cluster, they also start to populate here in the user interface, where you might have to take action on that remotely. Now, that's high availability, and that's the resiliency that's built into HD3 and why it's so important. But what we don't commonly talk about is the scalability of the system. You're talking about really small form factors and being able to deploy these across multiple sites. Scalability is no longer just the ability to scale out the cluster itself. So as new things come on, it's great that we can add additional nodes that don't necessarily match CPU or storage or anything. You can kind of scale out as needed to match the requirements of the environment. But scalability in this context is, how are you going to manage? How are you going to orchestrate? How are you going to deal with the fact that you have hundreds of sites? And so this is kind of a nice, simple, single interface to be able to manage across all those individual sites. And so it's kind of populating up all of the disconnected clusters, critical alerts, warnings, info alerts, all those types of things, alongside being able to do things like applying an update. And as I mentioned, the updates that we provide are everything from the firmware and BIOS all the way up through the storage stack and the hypervisor. So it's kind of all in one without any downtime in those running environments to be able to do those rolling upgrades. Let me stop sharing and we'll head back over to the slides here. As promised, there's just a couple slides left here, and then we'll get to any questions that I can answer. But I thought one of the use cases that I thought might be interesting to talk through is this Northern Marine use case. So Northern Marine has about 80 ships worldwide. It's in the marine industry, so these things are going through international waters, and you can imagine the ship operation applications that they're running here have to stay up and running because they're running important things for the crew, and as well as the cargo management, accounting, all the simulation and training videos and things that they have to have on there, in addition to just some of the basics of firewall security, file print type services. All those things have to run and stay operational. Meanwhile, these things don't necessarily have a constant connection to the internet. They only have that connection whenever they come into port, typically. And so autonomous operation is vital in this, and this is one of the more successful deployments that we've seen out there. More successful as defined by, I just think it's about the edgiest possible use case you could ever talk about. As I mentioned, Delhaize, other companies that I've talked to, even if they are land-based, have connectivity issues, but this is about as extreme as it gets when you're telling a story of autonomy for running these things out at sea. And whether you're running them out at sea or you're in, state and local government or in education or, maybe running a chain of hotels, if you're running mission critical applications out at the edge of your network, you need simplicity in your environment. HD3 provides that in spades. And I think with that, David, let's open it up to questions.
Absolutely, yeah. Great presentation. Really love you taking some time to do the demo there. That was cool to see it in action. You all have updated the interface, modernized it since I last saw it, so that's really cool. Some cool improvements there. I'm just going to bring up this poll question for everyone out there in the audience. We want to get your feedback on this. What additional information would you like about the Scale Computing solution? And so let's now go to the questions from the audience. Lots of good questions coming in. If you have a question for Craig at Scale, now's the time to ask it. Terry's asking, here's a good one. What about training? She wants to know what kind of training would be required to operate the Scale HC3 infrastructure, and do you all offer it?
So, to be honest, there's not a lot of training that's needed. I mean, the demonstration I just gave you, congratulations, you're now certified on running HC3. In reality, we do have a handful of training courses available. A lot of them are targeted at edge customers and at MSPs that are going to be providing these services, across multiple sites. MSP is actually, I would consider that edge in a lot of ways because you're kind of a centralized resource that's monitoring a whole bunch of remote sites if you've got clients running physical infrastructure on premises like that. And so for those customers, we have everything from, how just general overview of how the system works and how to operate with it, but also something more specific along the lines of that deployment and automating that deployment and, all of the goodness that goes around with getting things out and deployed.
Excellent. Yeah, that's something I've always appreciated with Scale. It just seems super easy. Another comment here actually from Scott, who says we use Scale HCI in the Neoshu School District, and it's excellent stuff. So that's great to see.
Fantastic.
Yeah. Brian is asking about automation tools, if they're going to roll out to 50 locations or whatever it might be. Do you all recommend or offer any sort of automation tools like Puppet or Ansible, he mentions, for that sort of scalability or rollout?
Yeah, we do have some integration with Ansible that we can get you access to as part of that rollout. Most customers right now are just using the REST API for defining a lot of that stuff alongside, kind of an on-premises version of zero-touch provisioning that I had mentioned with the USB. So the way this works is you basically create a configuration file, put that on a USB, and in that file you're defining all the IP addresses, all of the cluster setting information that you would want as associated with a specific MAC address. And you can have hundreds of these things in a single configuration file. Put that USB in the back of the nodes, and when it boots up, instead of it reaching out to hd3.scalecomputing.com as part of the registration process, it will just look locally for that configuration file as a starting point, and it'll go through initializing the nodes, initializing the cluster. You can even do some scripting to do some of the workload generation as well, to kind of bring on workloads as part of that. So it's pretty flexible.
Very nice. Another question here, they're asking about the software licensing costs. What's the model for that?
Yeah, it's a great question. So we ship everything as an appliance. I'll say that out of the gate. And by everything, 90% of the things that we ship. You can just buy the software, but almost all the time, what people will do is they will come to us to buy the hardware and software combined. We ship that pre-integrated so that you can go from unboxing to starting to create those virtual machines and other workloads with little overhead. The software licensing itself, it's core based, and so basically as the cores go up, the price will go up linearly up to a point, and then it caps at a certain point. And then we also have for these larger edge customers that are deploying tens to hundreds of sites, we have what's called a site license. And so with that, you don't necessarily have to license the cores itself. You're licensing the cluster, and whether that's a single node system or a replicated pair or a 3-node plus system, it doesn't matter what the resources are. You're covering the site license. And I will invite you as just kind of a next step is to go to our website. We're pretty transparent with the pricing on there, and you kind of go through a few different configurations to see what that would look like comparatively. But I can tell you that at a high level, product management, we're constantly looking at competitive landscape and making sure that our price positioning strategy holds. And our price positioning strategy is typically that we're going to be under most of the other HCI vendors out there, the Nutanix, the VMware, all of those we will typically come in under.
Very nice. Yeah, I like that transparent upfront pricing model. Matthew's also asking about costs as the sites scale up. So, maybe the compute scales up without storage, or maybe storage scales up without compute. What typically happens in there, and what can you do to keep the costs still affordable?
Yeah, that's a good question. So I would say probably the most common scenario that I see right now is that people will expand most common scenarios, people are just going to add additional nodes. So that's going to be compute and storage combined. It's going to be aggregated into the cluster, and everything's going to be seamlessly pulled together and ready to roll. But I would say the most common scenario outside of that would be that the storage starts to expand beyond that of the compute. That's what we're seeing right now. And for those use cases, we have what's called storage-only mode. So you can add a node to the system, even in a 3-node configuration, where you really only have 2 nodes worth of compute and 1 node that's just participating in the storage only. So you have all the high availability that you would have in a 3-node system. You've got rolling upgrades and all the great functionality that we just talked about, but you don't necessarily have to pay Windows licensing costs on that third host if the compute is not enabled.
Got it. Okay, I like that. And then you talked about scale as an edge solution, but there's a question here from Vivek. He's asking if this would work as well for a medium-sized enterprise, and I'll add on to that and say, will this work for really any size enterprise?
Yeah. So it's if you go back, actually probably David, the last time you saw the user interface, our bread and butter as a company for the last, and I've been with the company for 11 years now, for the last 14, 15 years has really been, we target small to medium-sized businesses. And we did that intentionally because these businesses are completely understaffed. There's no way you can be the person answering the phone of the CEO who's having email trouble as well as dealing with the infrastructure itself. It's just kind of a jack of all trades IT scheme. And we developed this product and all the state machine technology and everything to make sure that this stays up and operational so you can just set it up and forget about it. It was specifically for that SMB dealing with just a single site or maybe a site and a failover site. As time has gone on, we recognized that really we had developed that product unintentionally for any place that has limited to no IT resources. So it just happens to be that edge computing matches that on any individual site level. But the SMB, even mid-market companies, really do have a lot of success with HD3. I would say we're not going to go in and win the data center of a Fortune 500 company. That's not a target of ours. But I would say SMB, mid-market, kind of mid-sized enterprise type of companies, as well as those companies that have multiple sites. And again, it's going to be across retail, it's going to be in manufacturing, healthcare, you name it.
Excellent. Excellent. Well, Craig, I know we could probably chat here for another hour answering all these excellent questions that are coming in, but I'm afraid we've run out of time here in our live Q&A session, so we'll be routing these remaining questions to you electronically. But thanks so much for being on. Great presentation.
Perfect. Thanks, David. Take care.